I guess I'm the only one who's awed by being at the Salk Institute. So I have to take a second and say, woohoo, I'm presenting at the Salk Institute. This really is, like really, this is just normal for everyone. This is an enormous, enormous privilege. So thank you so much, Anpa. We had the perfect segue into our talk, so thank you, Jay and Melissa. That really is the basis for where this entire conversation is going to come from. Before I start a little bit on how Dr. Pati and I came to collaborate, we are both members of the Advisory Council for the Red Center, which is an outreach arm of American Outreach Resources. It's very recent, but what the Red Center is looking at doing is really producing and disseminating original research on human behavior, perception, and a lot of emphasis on visual environment and art. So they're looking to support research that's done in academia. I love this quote by Huxley: there are things known and there are things unknown, and in between are the doors of perception. And really, that sums it up. All we know is through the doors of perception. Now, we are at an interesting time, and especially with this group of people, that relationship between people and place, it's not a new one to study. Like John Zeisel said before, that we've been studying environmental psychology for many, many years, the relationship between people and place. But trying to go from that macro scale of something like a city to the micro scale of what's in the brain, and it was revolutionary, I think, for me to think about it, even though I've been looking at the neuroscience literature, when I saw Rusty Gage's talk in the morning about the level of detail that you can go into once you look at the micro. So how do you match those two completely different scales? And while the analogy works, that notion that you have two groups, and what are the subgroups that really create those meeting places? And we posit that maybe the visual image can serve as a common unit to start this dialogue. If you think about it, architecture does rely on visual images to conceive, design, present, even experience environments. And a lot of fMRI experiments use visual images to study the brain response. They use the images to invoke a brain response. So maybe if we look at the visual image, then we might have a place to start. Maybe that can be a common ground, a distilled unit for us to focus on. Like Melissa said, we already know probably more than we need to know on the impact of nature images. There's a lot out there. It's been tested in all different modalities: video, VR, visual art, and of course the view of actual nature, metrics, heart rate, blood pressure, cortisol, pain medication, anxiety medication, length of state, self-reports. A lot of metrics that say that yes, we do know nature images, especially with some attributes like focality, depth of field, so on and so forth, impact stress, pain, anxiety, and memory. And we have decades of research to prove this. What we still don't know is why at the level of neural behavior, and we still don't know what in that specific nature image worked. Going back to your point, saying if you abstracted it, if it was just the colors, is it the greens that are working and not the image itself? So we still don't know, which is surprising given that we've had so many years of looking at this. And that really was the driving force for this initiative. So here's what we started doing. We said, let's do a literature review where we try to match, we dig into the neuroscience literature, but with our interest in the visual properties of the images that have already been used in fMRI experiments. So we were looking at the literature, but with a different lens, with an architect or a designer's lens. We wanted to match brain response to visual properties of stimuli as pertinent to specific emotional states. Now, the overall context of this was in the healthcare context. What we were really looking at was the restorative impact. Technically, if an image is restorative, or if you want that restoration response, you should see that physiological body response to it between 4 to 40 minutes. That's what is described or defined as restoration. So we said, can we go back and look at these specific emotional states, look at neuroscience studies around it, and see what images those studies used, and then we will look at the images and say, what do we understand as designers and architects from those images that have already been used in experiments? So this was a grant we got from the Center for Health Design. We had University of Houston as a collaborator. It was a literature review where we used the keywords of the emotional states we were interested in: fear, pain, anxiety, fMRI, visual, and we just looked at PubMed. And we, of course, could have looked at other databases, but PubMed is pretty extensive. We found lots of articles. We found hundreds of articles which used visual stimuli, probably thousands, but very few of them addressed the specific properties of the image, because they were looking at the emotional state. So they were not trying to see what was it about the images, really. Were they trying to distill those? So those are the articles we were interested in looking at. Now, the emotional states, like I said, we identified as pain, anxiety, and fear, very, very pertinent to the healthcare context. We learned early on, we usually, at least in healthcare, we tend to talk about stress as an emotional state. We learned that it's really a physiological manifestation. It's a response. It's not an emotion. And we also learned from the literature some very prominent subcortical brain areas, the amygdala, the insula, the thalamus, and the hippocampus, that kept coming up. But for us, what was very interesting is to learn that the limbic regions, the regions which are in the hindbrain, act as a relay center for the emotional salience of visual information. Think about that sentence for a minute. What it means is every time you're getting visual information, someone is relaying it in terms of its emotional salience forward into your cognitive centers. And that was a great insight to get from a design perspective. Now, this is what we did, and this is just to show that we are very organized about it, but we're not going to go into it. But Kyle, if you're in the audience, I'm going to share all these articles with you. These were the shortlisted articles that look at the physiological responses. We had 35 total articles and we very clearly delineated what was the metric, what specific visual stimuli was used, and what was the specific visual property if they talked about it. And then we did the same with the neuroscience articles, with the fMRI articles, where we looked at, was it an experiment or a review study? What kind of emotional state was investigated? And again, what was the property of the visual stimuli, of the visual properties that they were looking at? And we didn't find a lot of detail in a lot of the articles, but it gave us some great insights, and that's what I will share with you. Kate, how many minutes exactly do I have? 13. Okay. All right. So this was one of our very early discoveries. This is not exclusive to neuroscience, but we realized that the IAPS, the International Affective Picture System, which has a database of almost 1,000 images, that's what is used very often with the fMRI experiments. And we found a compass, if you will, to how you can sort images in terms of their emotional property, in terms of valence, which is positive to negative, or arousal, which is whether it's exciting or not exciting. It's a great way to think about any image in terms of its positive to negative or valence value or the arousal value. What is also interesting, given that we had all these decades of knowledge on these physiological responses, we learned that the cortisol responses are linked more to arousal. So technically, you could have a very happy image, but if it was too exciting, you would still get an arousal response. And that sometimes is what you're going for in a museum or in Disney, where you're really trying to get people excited. Probably not restorative. So you're looking for high arousal. It's not always a bad thing. It can be positive or negative. Valence, on the other hand, is what affected the heart rate and the facial muscles. So it gave us a way of teasing apart the specific emotional property of a visual image, which you can then translate forward to a theme or to an overall design. And again, like I said, high arousal in a pleasant image can also be stress-inducing. There is a study by Koss, again in the 90s, which actually shows that blood pressure in intake patients increased when they showed some positive nature images. So those were nature images, but the BP shot up because they were very arousing. They were very exciting images. Another insight, which was again, very interesting, both from the visual art and the design perspective, is the whole notion of ambiguity. And this also goes back to how we respond to people. We found out that the response to indirect threats is sometimes higher, more pronounced than responses to direct threats in the fear center of the brain. So if you're looking at an angry face versus if you're looking at a fearful face, the response in the amygdala is probably higher for when you're looking at the fearful face, because it's an indirect way of talking about the threat. You don't know what it is that is threatening you. and the ambiguity really affects you. And again, you go back and think, what does that mean for design? What does it mean when we are trying to get ambiguity, which we do often when we are trying to engage a person? So it might be a great tactic to engage someone, but do you do it in a situation where a patient is under very high stress? And I love the comment earlier about the paradox of design, because you really have different situations that you choreograph for patients or for people as they go through spaces. I'll keep saying patients because I work almost exclusively in the healthcare context, so excuse me there. Another very interesting set of studies that we found was around realism and novelty with the pain literature. So we found that neural activity that was associated with empathy for pain was higher in responses to realistic pictures compared to cartoons. Real objects, and this is another body of research which I will talk about in a bit, out of Harvard, that says that real objects are preferred to meaningless novel patterns. And novelty, again, is a critical stimulus dimension for amygdala engagement, in addition to valence and arousal. So what we're talking about is that when you have something novel, that relay center lights up immediately again. And again, if you want to create memory or trigger memory, that's a good thing. If you want to have them relax, it may not be. So thinking about novelty in its various dimensions is also something that is worth investigating. I'm going to skip this one. It was another insight that we got about spatial frequency. And what this was is really trying to understand that every image has a low spatial frequency and a high spatial frequency component to it. Properties that you can extract immediately and those that you extract after a little bit of time. And that the amygdala response in that relay center, that fast, quick fight or flight response, is really on that low spatial frequency image. And what it means is that you respond to an image in your fear center, in that emotional center, even before you recognize what it is. And that relays into this piece of research that we came upon by Barr's lab in Harvard, which really was the aha moment for us in terms of the design significance. This is a fascinating piece of research. They compared the amygdala response to curved objects and sharp-edged objects. And they were studying the neural response. But they had just meaningless patterns. They had everyday objects, like a sofa or a watch or a can or just a pattern that didn't mean anything. No semantic connotation with fear. And yet, his studies found that the sharp contoured objects got an amygdala activation that was significantly higher than the curved contour objects. Now think of that in terms of the implications to the design field. And this was really amazing to us to come upon, and we literally came upon it when we started looking at the literature. Preference bias towards the visual object can be induced by low-level perceptual properties, independent of semantic meaning, via visual elements that on some level could be associated with threat. Our brains might be organized to extract these basic contour elements rapidly for deriving an early warning signal in the presence of potential danger. And that same thing might be something that in a museum might get a response that makes you look at a piece of art again and engage with it, and which in a hospital makes you look at a piece of art, get the fight and flight response, increase your stress levels. So this is how we got together with Dr. Pathi, and this is how we have actually embarked upon our very first fMRI project, where we really want to look about the response to form, just taking that little hypothesis further, sharp edges versus curved forms. If form follows function, can we really argue emotion follows form? And I'll let Debojyoti talk about that.
Thank you, Upali. Just a small bit of clarification here. Upali and I has been working for a long time. This is not the first project that we are having. The second piece of clarification is I'm not a neuroscientist. I'm an architect by profession, and I was working with HKS architects for a long time. I was the vice president of HKS in the healthcare sector. And that was when Upali and I started interacting. And I was not only the vice president and involved in design, but I was also involved in day-to-day research. So I was heading the research unit within HKS, which eventually became CADRE, which is the Center for Advanced Design Research and Evaluation, which I am heading even today. The reason I am telling you this background is that every day when I was in HKS, I had to, because I was in charge of research, I had to answer the question as to what does this mean to the design profession. And I think every architect in the room has the same question when they look at a piece of research. The first question is, what does it mean to me? And I kind of, have, after going through my tenureship at HKS for a long time, my brain started working in the same direction, that anytime I have a piece of information, it immediately triggers a response from me as to what does it mean to me as a designer. So, well, I was dealing with Upali, and she was at American Art Resources that time. Now she has moved on to the Center for Health Design. Every time we had a research, and she was doing a lot of research on two-dimensional artwork or two-dimensional visual stimuli, I would say. I would go beyond artwork. And then my question, whether I was asking her or myself, was what does it mean to the profession of architecture? I understand art is an important piece of the environment. And we, from certain angle, could look at the whole environment that we design as a piece of art, and sometimes we do. But the question is, art is essentially two-dimensional. And my interest all the time has been, what does it mean in 3 dimensions? When we think about architecture, or every designer, we start thinking in 3 dimensions and not 2. And the reason for that, one of the reasons for that was, as I was going through healthcare design, my main experience has been in healthcare and to some in education, which are very different from hospitality, where they deal with a lot of forms, but they don't really have to go through the whole logical process of justifying. And in healthcare, we have a clientele who really want an answer as to why we took a certain decision. And we throw out forms and justifications. I am not criticizing anyone because we don't have the information with us. But we do throw out a lot of different kinds of forms and attach a lot of meaning or a lot of hypotheses as to what kind of emotional response that form would give to the patient or to the staff. For example, we talk about things like hope. We talk about things like being elated or creating a refuse. And we create forms, whether it is cylindrical or like a chimney or like a ship, or any combination thereof, and somehow attach some meaning and some emotional response to it. And again, I'm not criticizing, but I think all the time when I was dealing with Upali, and Upali started this project with Houston a long time before I got engaged with fMRI studies per se at Texas Tech, my question was, can neuroscience begin to give me some information where I can justify my design decisions? So I'm looking at neuroscience from a very different perspective, that I'm an architect, I'm taking some decision. Can I go to my client and say, look, this is why we have taken this decision, because we have some very objective data. Now, so far, before I got into Texas Tech, my access was only to mainly behavioral research, mainly coming from psychology and sociological disciplines, some from the physical sciences. Never had access to the kind of equipment that you need and the technology that you need for neuroscience. So when I got into Texas Tech and got associated with our Texas Tech Neuroscience Institute, we kind of found, between American Art Resource Center for Health Design, HKS, and Texas Tech, found an opportunity to pool our information or knowledge together and begin to look at this question as to what does form and contour mean in terms of human response, neural response when they look at it. And this will, not only does it have an implications on justification of my decision to pick up a form, but for healthcare sector, it does have a tremendous financial implication. Because when we talk about form, we are talking by default about novelty in most of the cases. And I think 2 of the speakers today talked about novelty. And we assume most of the time that anything novel is good. But it may so happen, we don't know yet, whether novelty in a healthcare setting could have negative consequences also. We don't know that. So that's because we associate novelty with memory, and we want the patients to come back. We want the patients to refer other patients. Well, this is what we're talking about today in the next minute, is not about what I have done or we have done. It's our intention of what we will be doing over the next year. And because the first impression of healthcare is important to us, what we are looking at is a process where our objective is to begin to understand the neural correlates of formal decisions. And we will be looking at design forms, as I said, and very quickly, because we don't have the time now, I'm going to take you through the process. My intention is we don't have the time today to get your response in detail, but after this, if you can send us your email with suggestions, with comments, because over the next not only year, over probably several years, we'll be looking at this. So we'll be creating 3 different kinds of images, or 4 actually, starting with shapes, and then extruded shapes such as cylinders and cones and so on, that very preliminary in nature, but we do use those in design. And then go into objects and begin to look at interior spaces and how you experience the building from the outside. All of these through our fMRI, because it gives a much better resolution. Look at different kinds of population in different age groups, 25 to 35, 45 to 55, 65 to 75. Go through 3 phases with a priming phase in the middle. And all of this is being funded by the Red Center. Thank you so much. And I don't know if we have time for questions, but sorry about that long explanation on why we are getting into this. I think that was more important.